Welcome to Section 12.4, Second Degree Inequalities and Systems of Inequalities. Please note we're not covering Objective 3. So real quick, let's recall some of the steps for graphing inequalities. So the basic thing for an inequality is you want to first find the boundary. So one, determine the boundary. Okay, and you're going to state if it's solid or dotted. And then after you determine the boundary, you're going to pick a test point and determine which side to shade. To shade. And once again, how you determine which side to shade depends on whether or not when you plug your test point into your equation, it's true or false. That helps you decide which side you should shade. And then after that, when we're doing a system, the next thing you're going to do is graph the other one, the other inequality. Just the basic steps. That's if you're doing a system. Okay, so once again, remember the thing with the systems is graph one entirely and then graph the other. Don't graph both at the same time. Most of the times that's when a student gets lost. Alright, let's go ahead and graph the following inequality. Well, first we have to determine the boundary. What is this? Well, if we ignore the inequality symbol for a second and just put in an equal sign, do you recall what symbol this is? Or sorry, not what symbol, what equation this is. This is the equation of a circle. Yay! So, to graph this circle, we need to determine the center and then the radius. Well, the center is going to be 0, 0. How do I know that? Because there's no number being added or subtracted to the y values. So the center is at 0, 0. And then r is going to be the square root of 9, which is going to be 3. So let's go ahead and graph that, but first, do we have a solid or dotted boundary line? Well, because this is an inequality without that equal to symbol in the bottom, this is going to be a dotted boundary. And we're not going to write dotted line because it's not a line. Remember, this is a circle. So center at 0, 0, and radius of 3. Up 3, up 3, up 3, and up 3. And then I'll go ahead and dot in my circle. Alright. Now, the last thing I need to do is pick a test point to determine if I'm shading the inside or the outside. So, my test point, what can I pick? You can pick any point you want to. I'm just going to go ahead and pick 0, 0. And it's okay to pick 0, 0 because it's technically not on my graph. It's just the center point. The graph, remember, is the outside part. What I mean by the outside part is the dotted red line. Okay, so our test point is 0, 0. I label my test point. Once again, make sure to label your test point and show your testing. So let's go ahead and plug that into our equation. X squared plus y squared equals or greater than 9. Now what are we doing with the test points? Well, we're trying to see if this makes a true statement or not. So when I plug 0 in, I get 0 plus 0. And I'm trying to figure out if this is truly greater than or equal to 9. So is 0 greater than or equal to 9? No, 0 is not. So this is false. So since this is false, that means all the points inside here are not from my solution. They're false, so I'm not going to highlight them. I'm going to highlight all the points outside of my circle. However, if I had gotten my answer was true, let's say I had gotten my answer was true, then I would shade the inside of the circle. Because my answer is false, that means the side I got my test point from is false. So, my answer is all the points on the outside. Once again, whenever you do the shading, please extend your shading to the edges of the graph as much as possible. And there we go, pretty well. And then if you have an eraser, you can clean up the sides a bit. Some students like to use two different colors when they're graphing the systems. You can totally do that. Up to you. Okay, and there we go. We have our inequality with circles. Not too bad. Let me erase that true because that wasn't our answer. Okay. Moving on to the next problem. Graph the following system of inequalities. Once again, how do I know it's a system? Well, it has those little braces there. So what should I do? Well, once again, remember, for the system, you want to graph each one separately. So my first equation is x less than 3, and my second one is x plus 2 squared plus y minus 2 squared less than 25. So first, let's state the boundary. What kind of boundary do we have? Well, we have a dotted boundary. There's no line underneath. Alrighty, and then next we need to determine what kind this is. This is x less than 3. Well, if I just rewrote this with an equal sign, you'd notice this is a line. Okay, so this is just the line x equals 3. So let's go ahead and graph that in, x equal to 3. It's going to be right here. And we said it was a dotted boundary, so let's go ahead and dot that in. X equals 3 is that line. Now we need to have a test point to determine which side to shade. So I'm going to go ahead and pick 0, 0. Always the easiest one to pick. So I'm going to indicate that was my test point by writing test point 0, 0. And let's test it. So with the equation x less than 3, we're going to see if I plug in 0 for x. So notice there's no y value, and that doesn't matter. That's all right. We're just looking at the x, which is 0. Is 0 less than 3? And this is true. 0 is less than 3. So since it's true, I'm going to stick to shading the side that I got my test point from, which is going to be all of these answers on the left side. So every single point you could fit or pick from here would be a solution. Okay, that first one wasn't too bad. Let's take a look at the next one. Once again, same idea. Let's determine what the boundary line is. Well, if I rewrite this without the inequality symbol, can you recognize what equation this is? This is a circle, yes. Okay, so for a circle, how do I graph a circle? Well, I just need my center and my radius. Now my radius is pretty quick and straightforward, just the square root of 25, so that's going to be 5. And then my center is going to be the opposite of this value and the opposite of this value. So that's going to be negative 2, 2. That one, and then that one. Okay, let's go ahead and graph that. Negative 2, 2, right there. And then we have a radius of 5. So let's go ahead and graph that in. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my boundary was... Oh, I didn't state what my boundary was. Oh, no. All right. So my boundary, let's go ahead and write that, is dotted boundary. How do I know that? Because there's no line underneath my inequality symbol, so it's a dotted boundary. All right, am I done? No, I still need to draw in my circle, and then I need to decide which side to shade. So let's go ahead and dot in our circle. All right. Now, to figure out which side to shade, I'm just going to stick to the same test point, 0, 0. All right. And we're testing that with our equation x plus 2 squared plus y minus 2 squared equals 25. A lot of people like to use the center of the circle for your test point, and you can do that. I'm just showing you that it doesn't actually matter which point you choose, just the logic after you put that point in. So that's going to be 2 squared plus negative 2 squared. Is that... Ooh, I used an equal sign. Sorry about that. I should be using my symbol, which is less than 25, I believe. Yep. Using the symbol from my original equation. So let's see. We're trying to see if this is true, so I'm putting my question mark. And then we have 4 plus 4. Is that less than 25? Question mark. Well, that becomes 8. Is 8 less than 25? The answer is yes, this is true. So, since that's true, the side that I picked my point on is considered true, so I'm going to shade that side. And that side is this one right here. And then the last important step. So this is something I did notice on the last exam I graded. Some students only shaded the solution. And remember, the solution is where they intersect. So where they all intersect, the circle and the line, is right here. So some students only showed the intersection, and that is not what I would like to see. What I'd like to see is you show me the work for both shading. So show the shading for the line, which I showed in blue, and then show the shading for the circle, which is red, and show where they overlap. So you're kind of going to need, you don't need to have 3 colors, but you need to have 3 different shadings going on. Shading for the first line, shading for the second line, and then shade where they intersect. I'm going to look for those and I grade for those. Once again, if you have any questions on the grading, whenever you look over your exam and you're wondering how you got the grade, please stop by an office hour or just email me. I'll be glad to answer that and clarify anything. Alright, so that was it for that one. Let's go ahead and graph one more example for inequalities. Alright, real quick, small typo. Please go ahead and fix this. That should be an x squared on the top of the first equation. Alright, so taking a look at my 2 equations, I'm going to go ahead and write them out. Once again, we graph them separately. Can you figure out which kind they each are? And what I mean by which kind is what do they graph? Well, the first one might be a little harder, but the second one should be recognizable. This is a line. And what is the boundary of that? Well, since there's no line underneath my inequality, this is going to be a dotted line, or dotted boundary. And the first one, what would this be? Well, once again, always take a look at the exponents. That gives you a great idea. The y does not have a square to it, but the x does have a square. This is going to be quadratic, which means it graphs a parabola. Awesome. Okay, and then what kind of boundary do we have? Well, there is a line underneath, so this is going to be a solid boundary. Alright, so we have a solid boundary. So one thing to note, and this is where you don't have to do 5 points for a parabola. This is the only time. So let me go ahead and write this. Only time. You don't need 5 points for a parabola is with graphing a system of inequalities. Okay, so that's just for a system. If it's just a parabola by itself and you're graphing an inequality parabola, you need 5 points. However, if you're in a system of inequalities and you have a parabola, you only need 3 points. Okay, so we're only going to need 3 points. And that basically is the vertex and the intercepts. Alright, so let's go ahead and find those. Once again, we just need the vertex and the intercepts. So let's write this in an equation format we're familiar with. So set it equal to 4. And then let's solve for y. So y equals negative x squared plus 4. Multiply both sides by negative 1. I'm trying to get this to look like a format I'm familiar with. So y equals x squared minus 4. Does that look like a quadratic equation? It does. So for my vertex, v sub x, let's see. I'm going to start to label my vertex. V sub x is going to be negative b over 2a. And what is my b value? There is no b value because there's no x to the 1 power. So that's just going to be negative 0 over 2, and my a value is 1. Once again, there was no value with an to the x. There was no just x value, so my b was 0. The a value is, however, positive 1. So times 1, but that's still just going to equal 0 because you have 0 in the top. So my x value is 0, which means my v sub y, what's that going to be? Well, using my equation right here to solve for y, I'm going to take my x value and plug it in to my equation. So plugging in 0 from here, and we get negative 4. So my vertex is negative 4. Now we just need 2 other points. So I'm going to go ahead and just solve for my intercepts. So x intercepts, set y to 0. Then we get 4 equals x squared. Let's square root both sides. Plus or minus. And then we get, let me rewrite this with x on the other side, x equals plus or minus 2. So my intercepts are negative 2, 0, and 2, 0. Boxing my answers because we're kind of getting squished for room. So let's go ahead and graph that. My vertex is 0, -4. With a V, and then my intercept's +2, -2. And this opens upwards. And is it solid or dotted? It's going to be a solid boundary. So let's go ahead and whoop. Not the best, but it'll do with my arrowheads. Awesome. Now we need to determine the test point. That's the last thing. I'm just going to go ahead and pick 0, 0. I always do that if I can. The only time you can't pick 0, 0 is if your graph crosses 0, 0. That's the only time you can't pick it. So plugging that into my equation, y equals x squared minus 4. Oops, sorry, no. That should be x squared minus y. I'm going to use the original. It's a better idea to use the original. So that's x squared minus y equals, let's see, x squared minus y less than or equal to 4. And we're checking this out on the test points. Ooh, this time we do have an x and a y. So plugging in 0, 0, we get, let's see, we're trying to see if this is true. So, is 0 less than or equal to 4? The answer is yes, this is true. So since the answer is yes, that means we're going to shade the side that my point came from, which is going to be the inside here. Okay, we've graphed one. Let's go ahead and graph the other one. Once again, the other one is a line, and we just need 3 points for that. So let's see, for my line, x plus 2y less than 2, we're going to go ahead for my boundary, pick an equal to symbol, just for the boundary once again. That's the only time we use the equal symbols, just when we're graphing the boundary. Subtract x from both sides. What am I doing? I'm just trying to get this into slope-intercept form, because then it's easier to graph. Because then I can find my slope and my intercept. So, let's see, we have my slope, m equals -1/2, and then my y-intercept is 0, 1. Once again, I just got those straight off of here. That was my slope, my y-intercept, and then the next thing, I just need one other point, so my x-intercept. We'll go ahead and find that manually. Set y to 0. So we have, using my equation, let's set y to 0. We get 0 equals -1/2 x plus 1. Subtracting x from both sides, or sorry, 1 from both sides. We get -1 equals -1/2 x. Multiplying both sides by 2, we get -2 equals x. Ooh, that should have been by a -2, sorry. To get rid of that negative by the half right there. Which means this is going to be a +2. So my x-intercept is 2, 0. Alright, let's go ahead and graph these. X-intercept 2, 0, right here. Y-intercept 0, 1, right there. And we need one other point, so we'll use our slope to find that. Up, we can do back 1, up 2. So let's do that. Back 1. Oh no, sorry. I read that wrong. Let me write the slope on the side. So our slope is -1/2. So we can either do down 1, right 2, or we can go up 1, back 2. And I'll show you how that works. So let me erase the other one. Toot, toot, toot. So the first option will go down 1/2. It doesn't matter which point you pick from. You can pick from the x-intercept or the y. So down 1/2 from the y-intercept would give me my x-intercept point. And I could do it one more time, down 1/2, to find another random point. And this is, let's see, 1, 2, 3, 4. 4, -1. Or I could use the other directions to go up 1/2. 1, 2. They both work. So that'll be -2, 2. And then this line was dotted. Okay, so let me go ahead and erase that scratch work. Are we done? We're super close. We have to just figure out where to shade for the line. So I'm going to go ahead and use the test point of 0, 0 still, because my line is not touching that. And what is the equation? My equation is y equals, no, my equation is x plus 2y is less than 2. And we're testing that with 0, 0. So once again, go ahead, plug in your points. We're testing, is this going to actually be less than 2? So plugging in 0, 0 plus 0, is that less than 2? Yes, 0 is less than 2. This is true. So because 0 is less than 2, we'll go ahead and shade the side that our test point came from. So which side is that? That's going to be this bottom side here. So once again, show each line's shading, and then at the very last point, you're going to show the solution. And what is the solution? Well, it's where these two intersect. And where do they intersect? We'll just look for where their lines crisscross, and that's right here. This is the intersection, and this would be considered the solution of the system. So any point that you can find inside this yellow shaded area would be a solution. But once again, I want to see work for both of the shadings. Show me for the shading for the first line, and then for the second line, and show where they intersect. Alrighty. That is it for this video. If you have any question, please come by the office hour or send me an email. And this is the last section for our course. Congrats, you've made it this far. Thanks for hanging in there with me. Once again, please email me if you have any questions or come by my office hour.